Today we will explain a very important concept in network theory called Thevenin's theorem. Thevenin's theorem states that any linear and bilateral circuit can be simplified to a circuit consist of a voltage source VTH and a resistance RTH or Thevenin resistance. Okay, that means any linear and bilateral network we can change it to a this kind of circuit. But this theorem is only applied for linear and bilateral circuit. We cannot apply this theorem for a nonlinear circuit or a unilateral circuit. Okay, I think you understand linear and nonlinear, but maybe you don't know unilateral and bilateral. What is unilateral and bilateral? You know, right? For is VI characteristics, if this is V and this is I, then this first coordinate and this third coordinate, these two coordinate, the characteristic should be the identical, like resistance. For resistance, first coordinate and third coordinate is the same. That means resistance is a bilateral component. Okay. But suppose for diode, we know that it looks like this, right? That means first coordinate and third coordinate is different. Diode is a unilateral circuit. Okay. That means in simple way, in any component, if the current flow from this side is just equal from if the current flow from this side, then we call it as a bilateral component. Okay, if current flow from this side is not equal to current flow from this side, then we will call it a unilateral component like diode, transistor. But resistance capacitor is a bilateral. Okay, so the circuit consisting of the resistance and capacitance inductance, we can consider it as a bilateral circuit. Okay, we can apply Thevenin's theorem only for the linear and bilateral circuit. Now let's go for the example. For the Thevenin's theorem, there is two type of question. Okay, one type of question is they will give you the resistance, load resistance, and they will told you the corresponding current. Like in this question they provided if load resistance is 5 ohm, then the current will be 2 ampere from this one. Okay. Next is if the load resistance is 15 ohm, then the current will be 1 ampere. Now the question is if we replace this resistance with 35 ohm, then what will be the value of the current? In this type of question, they will not told you what is inside this black box. We need to consider it as a black box. That means inside this one, anything can be there. Okay, but they will not tell you what is inside. But they just told you the value of load resistance and the value of load current, like this. And they told you find out the load current when the load resistance is 35 ohm. This is a type 1 problem. So now let's solve this problem. As per Thevenin's theorem, we can simplify this circuit to a voltage source VTH and a resistance RTH in series. Okay, that means we can replace this linear and bilateral circuit with this one. Now just connect the load resistance. Then this will be like this, right? That means we replace this part. We replace this part by this one as per the Thevenin's theorem. Now it's very easy for you to calculate the load resistance, right? From here we can say IL will be VTH by RTH plus RL, right? And now they told you that if the value of load resistance is 5 ohm, then IL is 2 ampere, right? So for this one, we can write down 2 equal to VTH divided by RTH plus 5 ohm. From here we can write down VTH minus 2 RTH is equal to 10. Okay. Now let's use this condition and write down the equation. We can write down VTH by RTH plus 15 ohm equal to 1. That means VTH minus RTH equal to 15. So this will be equation 1 and this will be equation 2. Okay. Now, if we solve these two equations, we will get RTH is 5 ohm. Okay. And if we put this RTH value in the equation 2, then we will get VTH equal to 20 volt. Okay. Now, you already have the value of VTH and value of RTH. That means the value of VTH will be 20 volt and value of RTH is 5 ohm, right? Now in the question they ask if the load resistance is 35 ohm, then what about the load current? Equation is the same. IL equal to VTH by RL plus RTH. VTH is how much? 20. RL is 35 plus RTH is 5. Then we can write down is 0.5 ampere. Okay. This kind of problem only can be solved by either Thevenin's theorem or Norton's theorem. We cannot use any network theorem concept like the KCL, KVL or superposition. We cannot use that one. Why? As we don't know what is inside this linear and bilateral network. Okay. So for this particular type of question, you need to use the Thevenin's theorem. This is the basic application of the Thevenin's theorem. But we can also use Thevenin's theorem in our normal question. Okay. So let's go to a normal question. Suppose in the question they provided this one. This voltage is 15 volt, resistance is 5 ohm, 5 ohm and 5 ohm and 5 ohm. Okay. And they told you this is the load resistance A and B. Here this one is the RL, right? And they ask you find out the value of load current RTH, VTH. If we know the value of VTH and RTH, we can easily calculate the IL. So in my last video, I already explained you KCL and KVL, and I also show you the same example, the same network. I apply KCL and I apply KVL. I find out the value of I1, I2, I3. If you didn't saw that video, okay, I put the link on the description. Please go and check out that video. Now let's apply Thevenin's theorem for this network. For the Thevenin's theorem, I will tell you simple 3 steps. What you need to do. First, draw the equivalent circuit. This will be a voltage source VTH. Connect a resistance RTH, and then this will be load resistance RL. Here RL is 5 ohm. And now we need to find VTH to find RTH. Okay. Okay. So first we need to find out the value of VTH. What do you need to do? When you need to calculate the value of VTH, first step is the A. This is open load resistance. Okay. Then apply KCL on open node. Okay. Apply KCL and on the open node. Then you will get the find the value of VTH. Okay. This will be the process. So how to do that one? I just go to the next page. So our circuit is this is RL, right? So step 1. Step 1 is what? Take out the load resistance or open the load resistance. Then how the circuit looks like? like this, right? So now we need to apply the KCL at this node, and we need to find out the value of VAB is equal to how much is VTH. Okay, so apply KCL step 2. Here you can see step 1 is the open the load resistance, and step 2 is the apply KCL. Okay, so for the step 2, apply KCL at node A. What we can write down? We assume this voltage is VTH, right? And in my KCL video, I have told you that in this particular node, we assume that the voltage VTH will be max or higher than the any other voltage in this circuit. Then what we can write down? VTH minus 15 divided by 5 plus VTH minus 0 divided by 5 equal to 0. From here we can write down VTH equal to 7.5 volt. Okay, very simple. Understand? Now this is the find out VTH. Step 1. Okay. Now go to the step 2. Step 2 is the find out RTH. Now let's redraw the circuit first. Okay. What you need to do here? First step for the first step will be remove load resistance. Okay. Step 2. Replace the source with its internal resistance. Okay. C. Calculate RTH from load terminal. Open load terminal. Okay. Here I didn't say that replace the voltage source by short circuit. Why? If there is a current source, what you will do? So you need to know the general concept. The general theory is replace the source with its internal resistance. Okay. Here I write down for voltage source, what will be the resistor internal resistance is 0. For current source, 0 ohm. For current source will be infinite. That means if in the circuit there is a voltage source, you need to replace it with the 0 ohm or just do the short circuit. If there is a current source, what you need to do? Replace with the infinity. That means you need to do the open circuit. In our question, they provided is the voltage source. Okay, so what we need to do? We need to replace it with the short circuit. So let's go to the next page. I redraw the circuit. Then I will go step by step. So what will be the first step? First step will be remove the load resistance, right? Remove the load resistance. The second step will be what? Second step will be replace the voltage source with its internal resistance. Here is how much? 0 internal resistance. Then replace it with the short circuit. Now we need to calculate the value of this equivalent resistance of this circuit. Okay. So if we just move this one to this position, then we can draw like this. Just draw the A terminal in above. Okay. Now this is 5 ohm here and this is 5 ohm here. Here I draw the B in the bottom. So this two is the same circuit, right? Now we need to say what is the value of RAB or RTH. Is very simple. 5 parallel 5 or 2.5. But for some of you, maybe you don't understand how I did this one. Whenever you need to calculate the equivalent resistance or parallel or series, what you need to do, this is a pipe, okay, and then this is another two pipes. That means suppose you flow some water from here, then this water divided from this side and this side, right, and then this water will flow from this way and this way, right, and then it will meet again and go from this side. Whenever water divided in a branch or in a node, water divided in a node and go with separate branch, these two particular branch will be in the parallel, okay. Like if I show you just an example, this is R1, R2, R3, R4, and you need to calculate R equivalent. What you will do? Suppose think this is a pipe, okay, pipe network. What you will do? Just flow some water. That means the water will flow from this side, okay. It will divide it in these two branch, okay. Then it will meet again here, and then it will go here, right? That means the current or the flow in this particular resistance R1 and R4 is same, right? And the flow from R2 and R3 is just divided in this particular node and flow from R2 and R3. That means R2 and R3 resistance is in parallel, right? And R1, R4 and this whole R2, R3 combination is in series. So what we can write down? R1 plus R4. Why? As these two is in series, right? And this is series with the combination of the R2 and R3. And here we can say R2 and R3 is in the parallel. So we can write down R2 parallel R3. So this will be the equivalent resistance. We can calculate the equivalent resistance like this, okay. But in this equation, in this question, it's very easy. 5 parallel 5, so RTH is 2.5, okay. So we already got the value of RTH is 2.5, the value of VTH is 7.5. So replace this one in our circuit. We can write down here VTH is 7.5 and RTH is 2.5. What is our load? Our load is 5, right? So load is 5. Then what will be the value of IL? IL will be VTH 7.5 divided by RTH plus RL will be 1 ampere. If you recall the answer from the KCL or KVL video, I also get the same answer, is the 1 ohm. Sorry, 1 ampere. Okay. So in the same circuit, if we apply KCL, KVL or any kind of network theory, the answer should be the same. And we also get the same answer, 1 ampere. Okay. So I already explained the concept of the Thevenin's theorem and already show you two types of problem. This is the basic Thevenin's theorem problem, okay, and the fundamental problem, and another is the any type of network. In that network, how to apply the Thevenin's theorem, okay. The concept will I just summarize that one. What you need to do? First, you need to calculate VTH and RTH. For VTH calculation, you need to open the load resistance or remove the load resistance, apply the KCL at that particular node and find the VTH. This is for the VTH. For the RTH, what you need to do? Remove the load resistance and then replace the source with the internal resistance, okay, and then calculate the equivalent resistance, that will be the RTH. After you get the VTH and RTH, just replace it with its equivalent circuit and then you will easily get the value of IL. So let's go to the simulation and let's do this circuit simulation and just check the result is the same or not, okay. And I will calculate the VTH, I will calculate the RTH individually, and I will prove this whole circuit simulation data and this circuit simulation data, that means the load current here and the load current here will be the same. So let's go to the simulation circuit. Here we can see the circuit is same as our problem, okay, and this is the voltage of 15 volt, 5 ohm resistance, 5 ohm resistance, and this is the 5 ohm load resistance. I connect a ammeter to read the load current, okay. In from our calculation, we got that this ammeter will read the load current of 1 ampere, right? So let's simulate this circuit and see what is the value of load current. Here you can see the load current is 1 ampere, right? So our calculation result is exactly matched with the simulation result. And we already did this simulation in the KCL, in the KVL, right? So the answer is the same. Now I will show you how to calculate the Thevenin voltage. So what we need to do? We need to remove this load resistance, right? And connect a voltmeter in this A terminal and B terminal, in the load terminal, right? And we need to find out the value of voltage. From the calculation, we got the VTH voltage should be 7.5 volt, right? Let's calculate the Thevenin's voltage. So how to calculate that one? I already told you, whenever you need to calculate the Thevenin's voltage, you need to open the load resistance. Here you can see I already removed the load resistance and connect a voltmeter in the load terminal A and load terminal B. Okay. Now we need to simulate this one and we need to find out the value of the voltage VTH. This voltage will be read by this voltmeter. Okay. So let's simulate this circuit. Okay. So here you can see this voltmeter read the voltage of 7.5 volt, right? And that is exactly same as our calculation. So now we can say the VTH is 7.5 volt, right? Now what we need to do? We need to calculate the RTH. Okay, so let's calculate the RTH. So for the RTH calculation, how we can do the RTH? We need to remove the load resistance. I already removed the load resistance, and you can see I add a ohm meter. Okay, this is the step one. Step two, replace the voltage source by its internal resistance. Here we have a voltage source of 15 volt, right? And we already replaced it with the internal resistance 0 ohm. That's why we did it short circuit. Okay. Now, if I simulate this circuit, this ohm meter will read the value of RTH. Okay. Let's simulate this circuit. Here you can see the ohm meter reading is how much? Is 2.5 ohm, right? That means we already calculated the value of VTH is 7.5 volt and RTH is 2.5 ohm, and that is exactly matched with our simulation result. Now what we need to do? We need to replace this one by the equivalent circuits of the Thevenin's theorem. Okay. So I already did that one, and that is, sorry, this one, right? Here you can see that the voltage VTH, series resistance 2.5 ohm and load resistance 5 ohm, right? As I already told you, Thevenin's theorem states that any linear bilateral circuit can be simplified to a voltage source with a series resistance RTH and the load resistance RL, right? This circuit. And here, this ammeter will read the load current. Okay, so let's simulate this one. So here you can see the ammeter reads 1 ampere of current, right? That means this ammeter read 1 ampere, this ammeter also read the 1 ampere. So hence Thevenin's theorem is proved. And I already show you how to calculate the VTH, how to calculate the RTH, and replace these two by the equivalent circuit. And this equivalent circuit load current is the same as the normal circuit load current. Okay. So this is all about the Thevenin's theorem. Thanks for your time. Please do share this concept with your friends. And if you like this video, please press the like button. It is really means a lot for me. Bye bye.